Blub blub boys, it's us, BulletWhale, and today we'll be talking about networking. First we'll be talking a little bit more about how networking works in games, then we'll be discussing our own networking architecture and why it's a little bit unconventional, and finally we'll be talking about the concrete implementations that we're using. So let's discuss how networked multiplayer games work. If you are already familiar with the topic, then I suggest you skip on ahead in the video by clicking this link, and if not, then let's introduce it. So imagine we have two players, Alice and Bob, and both of them will be playing a game of chess over the mill. We'll start with Alice, who will move her horse to c3. She'll do the turn on her own board, then she'll write down the instructions, send them to Bob, who will then read the instruction and move her horse on his board to c3. Bob is then able to make his own move and he will move the black pawn to f5. And we'll do the same thing again, and Alice will then read the letter and move it. Now here we already have a quite good demonstration of how network games work. Instead of using the mill, of course, we are sending little packets over the wire, which represent the input of all players. What you then get is that the game state is updated accordingly. Now of course this model has some weaknesses, otherwise all games would be using it. One of the most important ones of it is lag. Because all the clients are connected to each other, in this case Alice and Bob, the slowest one of them determines how quickly the game will actually progress. Now you can imagine that will give you a lot of issues if you have a lot of players, right? All these players need to be connected to each other and they also need to be sending messages to each other. In that case, the slowest connection between any of these players will determine how quickly the game progresses. Now imagine that you're playing a racing game, right? It doesn't make sense that all players are driving slower because one of them has a bad connection. And this is why in games we usually don't wait for the input of all players. Instead, clients can be a bit ahead of each other or a bit delayed in the pause depending on their connection speed. Now, when you do that, of course, you're running into problems, right? Maybe some clients are getting too far ahead or some clients are staying too far behind, and we need to correct for that. Now, what we usually then do is this responsibility of correcting is actually drawn to one central computer, which we call the server. Now, all clients don't have to be connected to each other anymore, but just with the server. Now, moving these responsibilities to the server also provides you with some other benefits. For example, a safety benefit that you get. Now all clients don't have to be connected to each other, they don't have to know each other's IP. Another advantage is that you only have to be connected to the server in this model. So you don't have to send messages to all clients, which will reduce the stress on your network considerably. And now after this short introduction into networking, we're gonna be talking about how our networking architecture is structured. What we're using is a client hosting model in which one player will also act as the server of the game. The reason that we're going this route is because it's easier for players to just start and play with their friends, and also it makes it a lot easier for us to set up servers. In our game, players are fully authoritative. So what does that mean? Well, it means that the server will fully trust whatever the player is telling it it's doing. This means that if the player says I'm standing over here, the server will believe that and tell the other clients about it. It also means that when you hit an enemy with an attack, it will always hit. And also the server will trust the client to be honest about when it's hit by an enemy attack. Now of course this introduces a lot of risk regarding hacking, but in our case, since this is a cooperative game without any competitive aspect, we believe it's okay. If people are cheating, well, they're probably doing it to have fun and we're still achieving our goal in making people happy. Now the server is in charge of several things, for example the AI. The AI runs on the server and all behaviors are controlled by it. The server will inform all clients about the whereabouts and actions of the AI and will also maintain the animation state between clients and the server. The latter is especially important because most of our attacks are controlled through animations. Another thing the server is in charge over is spawning projectiles. Well, the projectiles are player owned, usually, unless they're of course spawned by an NPC. And their hit detection is also client driven. Creating them does happen over the server, and this is just because the server is the only one in the library that we're using that can actually instantiate objects. So let's now talk about how we actually implemented the networking. There were two options for us, Mirror and ML API. We got these two libraries from a Unity blog post listing all networking solutions available since the deprecation of UNet, Unity's own networking solution. The blog post, as indicated before, led us to Mirror or ML API. After looking through the features of both, we decided to go with ML API. We worked with Mirror in the past and also Unity, but ML API promises better performance, 10 to 30%, which is a lot. But also it has some really nice features, such as being able to call RPCs without having ownership of the object. Now, for those that never worked with UNet or Mirror, this will not make a lot of sense, but trust me, it's very nice, and for those working with it, there you will know the pain of sometimes having to scaffold around this limitation. Another thing that's very nice about ML API is that the source code is very clean and understandable, in contrast to Mirror and UNet. A disadvantage though is that there's still a little bit of bugs here and there, and the documentation is a lot sparser compared to UNet and Mirror. That's all for this video. I hope you enjoyed it. Leave a comment telling us what you like or want to see improved. Like or dislike the video, subscribe to follow us, and join the Discord to be kept in touch with the development of the game. Also, a big thank you for everyone providing us feedback on the last video. It really helps, so please keep doing it. And with that, I hope to see you all back here in the next video.